go again. Formulas of ionic compounds. I know you watched the second video right away because you were so excited about this part. Okay, the correct formula for an ionic compound. You're wondering, why do we do this? So basically, earlier we talked about ions, and now we're putting them together and make an ionic compounds. Yay! The thing about ions is you have a negative and a positive, and the idea is you're going to put them together and make something that equals 0. That's the plan. Okay, so the formula for an ionic compound, let's go back up here and make this red, is the smallest number of positive and negative ions which add up to a total of big fat 0. Yes, 0. So you're taking like a -2 and a -1 and you put them together, you get 0. If you take a -2 and a 1, you have to put 2 of these positive ones together because ultimately it has to equal 0. Okay, identify the ions and then decide how many ions of each type will make a total of, one more time, ladies and gentlemen, 0. Oh, I didn't put it in red. I know it'll be confusing for you if I don't. 0. Okay. What is this chemical formula actually telling us? So when you read a chemical formula, you have these subscripts and superscripts. What you're really telling us is that the chemical formula, what I'm really telling you is the chemical formula is actually a ratio of what? Negative to positive, which we like to call anions and cation. Oh, it's not red. To cation. Negative to positive, right? So how are we going to do this? In order to determine the formula, first we're going to write the formula. So here it is down here. We're going to write potassium, and we're going to look it up. It has a +1 charge. Then we're going to look up fluorine. Is that fluorine? And it's going to have a -1 charge. We're going to put those together. Boom. Didn't have to do anything. We're super smart. We're super awesome. We're doing awesome things. Or we have our potassium with oxygen, and oxygen has 2, so we have to use the subscript. You're going to be very familiar with these things in WordPerfect. I'm very familiar with subscripts and superscripts and how to do that up here in this part of your, well, I guess you're not. Nonetheless, this is called a superscript. This is called a subscript. So when you have you need 2 potassiums to equal out your -2 oxygens. So this formula is going to be K2O. This is not huge. It's actually not that hard. You're going to determine the number of positive negatives. Now, it does get a little bit harder. You have to do slightly more thinking. Again, same thing. Calcium and chlorine. Look at that. You need to use 2 chlorines to equal your 2+. It's simple math. It's simple. It's not very hard. Sometimes it gets more complicated. So I decided to make an example. Your book decided to make an example that was more complicated. I'm just going along with your book. So you have up here PO4, which has a -3 charge. Now, I realize this flies against the face of everything we're talking about. I don't know why they chose it as an example, but they did. Potassium does some bending of the octet rule a bit, and oxygen does some things, and together you get 4 oxygens bonded to this phosphorus, and with that, you get a -3 charge. Just trust me. That you don't have to know. That you're not coming up with. That I'm going to give you, or the book's going to give you this example. So here you have a -3 charge, right? You're going to bind that with magnesium, which has a 2+ charge. Oh my gosh. Am I going to do 6 with both? That's weird. Well, sort of, yes. So you're kind of just going to swap them. You know that 2 of these, 3 of these, you're kind of just going to put 3 of the magnesium and 2 of the ion over here. Does that make sense? If you look at it, if you think about it, you might want to pause the video, look at it and say, is that going to equal 0? Yes. 3 times 2 is going to give you 6, -6. 2 times 3 is going to give you +6, and it's going to equal out to be 0. So it's just multiplication. You're just adding to both sides. It's not actually as hard as it sounds. Trust me. Okay, so there's an example. You can look. There's other examples in your book. And again, if you have questions, let me know. But I think I give you some homework so you can play with that a little bit. Again, the goal is 0. You want both sides to equal 0. The positives and the negatives to come out and equal 0. Okay, naming the ions. Because again, it's just like naming babies. And who doesn't love naming babies? Everybody loves naming babies. Name the cation, then the anion. And you leave a space between. Do not write the charges of the ions. I don't need to know that. You just need to write the, do I have an example? I didn't give you an example. So write the cation first, then the anion. Use parentheses around a polyatomic ionic formula if it has a subscript. Don't worry about the salts of transition metals, because remember, transition metals, problems, they're just problem. We're not going to fuss much with the transition metals because you're not going to spend a ton of time with them or doing stuff with them. So I'm not as concerned about the oh so fun transition metals. Okay. What else do I need to tell you? Oh, acids and bases. Let's just move on to acids and bases. Okay, because now that we're done naming things. Okay, acids and bases. Do not worry, we have a whole chapter, I think 2 even. This is going to come up a lot. This is going to come up in physiology. Acids and bases. We really, really need to understand this because it just keeps coming up. You think you're going to be done with it in chemistry, and then I bring it back up in physiology like 3 times. And then if you go on in nursing and get into the nursing program, they're going to bring it up at least twice. In 2 different classes, you're going to have to know this. And then you're going to get people's blood samples back, and you're going to have to know the oxygen concentration and what that does when you hyperventilate. It actually is an acid and base because the oxygen is causing your pH to move. So it never goes away. Just learn it. Learn it now. It saves you tons of problems in the future. Okay, 2 of the most important ions are the hydrogen ion, cation. Okay, just a tip that I forgot to tell you. How do you know that cations are positive, anions are negative? And so the hydroxide leaves you with an anion. Oh, not red. I'll make it red so that you know that it's okay. The way I remember it is just that cation has a T. It kind of looks like a plus sign, and that's positive. Anion does not have a T, therefore it's negative. That's the only thing I have. You can come up with your own little thing there. Cation positive, anion's negative. So the 2 most important ions, so the reason we're bringing it up in this chapter is because we're talking about ions. The 2 most important ions are the hydrogen ion and the hydroxide ion. This is what makes up pH. This is what makes up all kinds of processes in your body. You have different pHs, and keeping these hydroxide to hydrogen ions straight in your body is super important. So we're talking about it now. This is just a brief introduction. Don't worry, we'll devote a whole chapter to it. Hydrogen cation is simply a proton. If you look up in the transition chart, if we go back up here briefly, you'll see that it just exists like that because hydrogen is weird and it only has 1, and so it just exists like H+. It just always exists like that. So now we go back down here. Okay, hydrogen just simply exists, H+. One of the definitions, which is the definition that this part of the book uses, is when an acid dissolves in water, the proton attaches to the molecule of water to form a hydronium ion. That's this hydronium ion. Just memorize that. I'm going to ask it. I'll just give you a point that I'm going to ask you. What is this? Hydronium ion. That's what it is. You need to know that it's a hydronium ion. Chemists use hydrogen and hydronium ions interchangeably. Yeah, it's like it's the same thing. We don't actually care if it's this one or if it's this one. Hydronium or hydrogen, we use them interchangeably because I think when they first started doing this, they didn't realize we were going to have to teach people who were not like super nerdy chemists chemistry. So they do things like hydrogen and hydronium ion mean the same thing. The importance of this hydrogen cation and anion is that they are fundamental to the concepts of acids and bases. So one of the definitions of acids and bases, this is really fun, is, oh, I'm on my page, provides hydrogen ions, which is H. I'm just going to make it a plus. It's not a subscript. You'll figure it out at some point. Maybe. No, I'll make it a subscript. Where's the positive sign? Plus. Hydrogen ion. Oh, no, take subscript off. Okay. Provides hydrogen ions, which would actually be the same as also providing hydronium ions when dissolved in water. Okay, you non-chemistry people, I bet you can see the problem with this definition already. But let's move on and then I'll tell you what the problem is. So a base provides, what do you think it provides? Hydroxide ions, which is OH negative. Oh, do you really want me? Okay, I'll make it nice. Negative. OH negative ions when dissolved in water. Oh, I spelled dissolved wrong. Really? Come on. Okay. Acids turn litmus red. Really? Red. And they taste sour. No reason to start eating chemicals in the lab. Don't do that. Just trust me, it turns litmus blue and it tastes bitter. Okay, so what do you think the problem with this definition is? It provides hydrogen ions when dissolved in water. Does every element dissolve in water? Does every compound dissolve in water? No. So thus a fundamental problem with this definition is not everything dissolves in water. So we will talk about a more advanced definition for acids and bases. This is just to sort of get you started because we're talking about ions and because the most important ions really, or some of the most important ions, are this idea of acids and bases. So the more times I say it, the more times perhaps you'll be like, oh, acids and bases, I should really learn that. Yes, you should. Again, acids provide hydrogen ions when dissolved in water. So when they dissolve in water, they produce this ion. Provides, oh, seriously, with the spelling today. Provides hydroxide ions when dissolved in water. So one will produce this, one will produce the OH, and it's just a matter of what is moving around there. Don't panic about this. This is all the information that you need to know for this chapter. We will talk more about acids and bases. Do not worry. Okay, this is all from chapter 3. The next lecture will be the beginning of chapter 4. Okay, bye-bye.